Are you on the blue team and you want to win? Well, try this, right? I call this canary. It's a concept, an idea that stems back from the late 90s, where you have a dark net, right? No, not the dark web, a dark net, or a dark network address space, right? Where you know that nothing there should be talking, right? You have a lone box that is silent and just waiting, right? And so I thought, laying in bed this morning, that why not construct our own canary, right? Why not give the win, the point advantage to the blue team this time, right? So what we did was we constructed basically an IDS, right? We're going to use Python. We're going to leverage like Wireshark, right? T-Shark, right? We're going to leverage those technologies, those packet capturing technologies, to report on the things that we want to report on, and just freaking score, right? Drive that point home, you know, push back that red team. Because the point here is that we're going to be, you know, see no evil, hear no evil, speak no evil, be silent, and when they trip, right, when they send that rogue ping, right, when they try to connect to an odd port, this box is going to report back to us to say, dude, something's happening here. I shouldn't be talking, period. Send up the flags, right? Call in the troops. We've got a rogue box in our network. We got to take care of this. So let's look at the topology here real quick, right? What we're going to do is we're going to construct a couple networks off of our core, right? So here's our core switches. And what we're going to do today is we're going to spin up a new address space, right? And what this address space is going to do for us is just be vacant, right? So let's say our address space in today's scenario is 192.168. Let's do a /24. It could be a slash, you know, heck, 30, right? A 31, depending on your topology. This happens to be in my lab. I got a lot of stuff in my lab, a lot of stuff that's talking to kind of give a point and how we can leverage this technology, what we can do to filter. So today it's going to be a /24. And we're going to do that Darknet or dark address space, right? So that's what we're going to do. So we're going to spin up a new VLAN within our core. And within this new VLAN, you know, of course, we're going to give it the appropriate address spacing and everything like that. We're going to put a box. I think that just changed the shape. We're going to put a box, right? Just my preference is Linux. So this is going to be Ubuntu, right? So we're going to put a box in there. And this sole purpose of this box is just to lay dormant, right? We're not going to run any web browsers, right? We're not going to run any services that our organization might need to conduct its business. This sole purpose is just to lay there, right? It's going to be like a praying mantis, right? It's going to be that canary in the coal mine, right? To just alert us when there's like poisonous gases, right? Alert us that, hey, we've got to take action because this should not be talking, right? So high level, right? We're going to construct this darknet, right? We're going to create this dark address space, right? We're going to create a Python script that's going to leverage PyShark, right? And Wireshark is going to use the Wireshark packet capturing technology, right? Specifically T-Shark, to look at those packets coming in, and for us to take that packet as an object, break it apart in the individual layers, like the IP, right, or the transport layer, right, for us to make a conscious, a logical decision on what we should do, right? And how cool is this, right? We've created our canary in the coal mine, and it's letting us know what this soul box is doing, right? So if you want to know more, if you think this is cool, right, you want to win, right, be on that blue team and just hit it out of the park, stick with this, right? Stick with me, and let's drive this home. Awesome. All right. So let's get started. First, you're going to need to install Wireshark. And depending on how or where and when you install Wireshark, you need to make sure that you also have T-Shark installed. Once you have Wireshark installed and T-Shark installed, you can install a package called Wireshark, right? So depending on what box you're on, it might be pip, it might be pip3, but you're going to want to look at the installation for Wireshark, right? It could be pip install Wireshark. So look at that. We're going to need to get installed. And I also like net eye faces. All right, that's going to help with some of the I call it portability, kind of being agile and don't repeat yourself philosophies. And with net eye faces, it allows me to say, hey, I'm going to write this script and use that library to determine what my egress interface is. So makes things a tad bit easier. And as we progress, I'll probably be adding a lot more libraries. But for you, I'd say that the main things are Wireshark and possibly net eye faces, right? And that's again a pip install. It might already be installed. I'm not sure. So to begin, let's do our import. So I'm going to import Wireshark, and I'm going to import net eye faces. Sweet. So with Wireshark, you got to tell it what interface do you want to start capturing off of. Same thing as like running Wireshark, right? Or T-Shark. What interface is our capture? So to begin, let's do this. I'm going to print net eye faces. Give me the gateways, and what I'm looking for is I want the default gateway and net eye faces. I need the address family of internet, right? So IPv4. That's what I'm looking for. Of course, you can do IPv6. I prefer, in this instance right here, make things a little bit more simple. I'm just going to focus on IPv4. And if I run this, what do I get? Sweet. All right. So that is my egress interface on this box, right? The one that the default gateway is attached to. So we're going to need that for PyShark. And so let's wrap that in a variable. All right. So if I go like int f equals net I faces, I want the gateway, give me the default, right? Boom, net I faces. So now the interface name should be in that variable. The other thing that we need to do for PyShark is to define the capture, right? And of course, you're going to want to look at the documentation page because you can apply some filters to the capture like you can with Wireshark. I want it all, right? So let's do capture PyShark. We're doing a live capture, and my interface, you got it, int f. All right. And let's set up a loop, right, for packet and capture sniff continuously, right? So every time a packet comes in, right now, let's just print, right? Print that packet. And if we run, well, what do we get? Of course, we get packets, right? Cool. All right. So let's do one other thing, all right? And what that other thing is I'm just going to create something for me to explore what's in packet, right? So to explore, I will just do Jack equals Jill, right? And before we print the packet, I want to put a breakpoint on that print statement. I will start and explore what's in packet. All right. So it looks like we have some information here, right? It looks like that we can explore ARP, right? If it's an ARP packet, we can get some of these fields. I'm going to suppress ARP. What I want to look for is layer 3. And anything that is private address, RFC 1918, to this box, right? I'm not looking at it from an outside in or an inside out. I'm looking at inside to inside if you're talking about like firewall zones. And that's what I want to capture. I want to capture that bad guy already in deep-seated rooted, right? I want to see that lateral movement, right? That's what I want to key on in this particular canary. Of course, you can do however you see fit. So that is an ARP packet. I don't necessarily want an ARP packet. So let's see if we can't get that spanning tree. So we might have to do some more filters. To bypass, right? Awesome. Okay, cool. So thank you for bearing with me. All right, so we got TCP, and if we look at the highest layer field here, it says a TLS. Okay, cool. We can work with that. All right. So what are we wanting to do? Okay. So what I want is the IP address. I want of course, the source and destination of the IP. And if we look at TCP, you know, that transport, I want the destination and source ports. So those are my two big things. Cool. All right. So let's get started, right? So this is the basic construct of PyShark in capturing traffic continuously. Of course, you can set up like a ring filter. You could set up, hey, only capture 50 packets, or you know, capture like 30 seconds worth. For our case, or my case right here, right now, I want to do a continuous packet capture because I want to look at everything coming in, parse it, and then report if it's private or private. Cool. All right. So let's do this, right? All right. So I don't know. First things first, I guess, is to determine if it's private, right? Private addressing. So I'm going to define a function here. Is private IP, and we're going to suck in, let's call it IP address, right? And let's give it a little bit of commenting here. Let's say something like determines if the given IP address is private, right? RFC 1918. Yeah. To do that, we're probably going to need to suck in another import. So let's do import, I think it's IP address. Cool. Okay, our args is IP address, the IP to check, right? And then we're going to return true if the IP is private, right? That RFC 1918. And we can do like type hinting, right? To kind of help us our future selves. So this is a string, and we are returning a bool. Cool. To get to the awesome sauce, I'm going to delete that a little white space, and then come down here and say IP equals, what is it, IP address, and we're sucking in IP address, right? And then return IP is private. Cool. All right. We are also probably going to need to start doing some filters because of what we saw, STP, ARP. So what we want with packet is the transport, right? So let's start constructing a filter. And of course, you know, if this being like Wireshark, you could actually pass in a filter for the capture, but I want to return everything. But I still need to filter it. So let's do something like define a new function. Call it filter, and let's call it packet, and let's do a type hint to say it's capture. All right. and let's say filters packet on below stuff, right? Args is packet. The packet from the capture. Yes, awesome. And I really only care about TCP and UDP and ICMP. So let's start looking at that, right? So let's start doing if no, let's if packet transport layer equals TCP or packet dot transport layer equals UDP, then do stuff, right? So what stuff do we want it to do? Well, the end goal is for it to dispatch a message. In order for it to dispatch a message, we have to feed it some information. Let's define an object. And what this object is it will essentially be the message that we're going to pump to our canary, right? Our message board. So we come up here and let's do class packet. We're going to define self. What other information do we want in that packet? Well, we're going to want the IP source. Just a second. I think we need to follow the naming convention of PyShark. So let's come down here. We got our breakpoint. Let's go start. What type of packet did we get? We got a UDP. Cool. So within IP, I got dest and I'm suspecting source. Yep. Alright, cool. And I think we also want a timestamp. Yeah, sniff timestamp. Alright. So let's come back up here. We're going to delete our source. And then let's do timestamp. It's a string. We're going to give it a default parameter or value. Let's do IP source type hint, it's a string. Default parameter, IP dest, right? It's also a string. Default parameter. We also have source port, right? That's going to be a string. Let's do a default parameter. We got a destination string. Right. Let's also pass in if it's UDP or TCP. Let's call that transport layer. That's also of string and default value. And they also have highest layer. So let's also do highest layer. Highest layer, that's string and a default value. Cool. And at any time, if you want me to share this code, drop a comment, right? And don't forget to hit that like and subscribe. So we're going to do self timestamp equals timestamp self IP source equals IP source. IP destination is equal to IP dest, right? We're just going to go down that line, paint ourselves a nice happy cloud. And we also did transport and highest. Okay. Self transport layer equals transport layer. And then this nice little bubbling brook here, highest layer. I think I spelled that wrong. Looks wrong. Highest layer. Highest layer. Cool. So we've just defined our object. Now we could use that object, right? So we come back down here within our filter, and we're saying if packet.transport layer equals TCP or packet.transport layer is UDP, do something, right? Well, what is that something? Well, let's create an object, right? So let's be it's a local variable, so I'm going to go underscore. Well, I would like to call it packet, but packet's already used. I don't know, datagram. If you can think of a better one, write it in that comment, man. Is of packet. All right, cool. All right, so I think I do not want any IPv6. So let's do something if has attribute packet IPv6. I wonder if we can just say the hell with you, right? Return none. Bail. Let's give it a comment. Bail if IPv6. Alright, so our packet is TCP or a UDP. We don't want IPv6. If has IP, right? Then we want to do something. We really want to start plugging this apart. So our packet is TCP, UDP, and then IPv4. Sweet. So if we're IPv4, let's check to see if we are private. If is private, right? And what are we passing in? Well, the packet IP, and it was source, right? Let's do true. We're going to encompass this in a I need an and, not or, and is packet IP, right? What we're doing packet IP dest is true. Then do this, right? So what are we saying here, right? What we're trying to say is, are we a private IP address, RFC 1918, for the source? And are we RFC 1918 for the destination, right? So this is internal to our network. So if we are internal, let's start looking at the parameters, or stuffing our object. So datagram, and within that datagram we have IP source. Well, IP source is equal to packet.IP source, right? IP dest is equal to packet.IP dest. What else do we have? We have, let's do timestamp, right? Is equal to packet.timestamp. Yeah, buddy. And we have datagram, highest layer, and it should be packet.highest layer. High test? I don't think it's high test. Highest layer. Are we? Awesome. All right. So let's look at this. All right. We defined a function. Within our function, we're saying, are we TCP or UDP? If we are you IPv6? If so, get out of here, right? If we are IP, right? IP version 4. All right, let's start dicing this up. Cool. All right, I think logically it sounds plausible, right? Okay. So we also need to know transport layer, right? Is that one of these? Yeah, transport layer. So is it UDP or TCP? And if we look at how it's laid out, packet, UDP. All right, so I'm suspecting packet.udp and then packet.tcp. So we're going to need to determine if this packet coming in is TCP or UDP. I'm suspecting, right? So we don't need that anymore as a placeholder. So let's say something like if has attribute, and what we're looking for, let's say UDP. All right, so if we are UDP, we are going to say that works. Desport is equal to packet dot UDP dot desport, I believe. Sweet. All right. And then we also have, you got it, we also have that source port that we need to fulfill, right? So packet UDP source port. Cool. Awesome. And we have transport layer. So datagram dot source port. Excuse me. No. Transport layer, right, is equal to packet dot I think we can just do transport layer, yeah. Packet dot transport. We can do that outside. We don't have to be inside that if statement, because if we're inside that if statement, we'll have to type again. Datagram, and we're doing transport layer. Transport layer is equal to packet dot transport layer. Something like that, right? Looks good. Cool. Then we come down here. We also have TCP. So if has, right? So we're checking to see if packet contains UDP. Right, and if it does contain UDP, do this, right? If not, if packet basically contains TCP, right? We come here, contains TCP, then we have to do this, right? And the reason why we have to do this is because if we look at it from here, right, it's different. So equals packet TCP desport. Datagram source port is equal to packet dot TCP source port. So that's what we have to do to ensure that we don't throw an error, right? Because We don't want to throw an error. Errors are bad. Really, really bad. All right, cool. And now we've got our packet object constructed. What do we want to do with that? Well, let's, for the sake of argument, we can report, right? So let's come back up here and report. For me to report, I want to dispatch that packet to a remote server. We could log it to a file. We could probably do a syslog. I want to do a remote server, and that remote server is listening on port 80, so I'm just going to do a get and shove it in as a query, right? Kind of cheat. To do that, I need some information, right? The information that I need is the destination server, the one that's running that HTTP, right? That web server. And port. So let's do an object again, right? Objects are really easy to use. So let's say, I don't know, API server. All right. Let me know what that is. Initialize, we're doing self. I said that I need an IP, that is a string, and then I need a port, and that is also of string. And you notice that I did not specify any default values for the property of IP for API server. That is different than our packet object, where we can specify where we specified a default value. And that is because when I go to construct this object later in the code, I'm going to provide it the information up front. I know what it is. So self.ip is equal to IP. Self.port is equal to port. Cool. So anything being passed in for the IP parameter, right, will be that property IP. And likewise for port. So we have that object. Let's use that object right here. So let's do a global property, and that global property will be equal to, right, or global variable will be equal to API server. In lab environment, it is 192.168.2.32, and I'm running 8080. Cool. So in our code now, to specify the parameters of our remote web API server, all we really need to do is type in server dot, and we have access to IP and port. A lot easier to move around, So if we move this to, let's say, another area of our network, and the reporting server will be different, we just need to change this one section in the code, and it will be changed for all the other places that we've referenced server. How cool is that, right? Before I forget, let's change that back. You know, it dawned on me, doing this, I think we need to look at our filter. Because we're going to pick up our transmission to our reporting server, so it's going to be like this vicious loop, you know? I'll quit it, right? So let's go up here. And let's put a placeholder here. And what that placeholder will do is just remind me that I need to filter out the conversation to our reporting server. To do that, let's go up to here. And let's do something like, because we need to check for if we're communicating to our server, right? So we need to do define a new function. And what should we call this function? I don't know. Is API server? And what do we want to pass in? We're going to pass in, we need to determine from the packet the source and destination IP to see if either one of those match. So let's do packet, and that is of capture. And let's also, that would do it. So this is saying that we don't know what you mean by capture, because capture is defined down here. So we should move our global right after our class. Delete, right? And now capture is happy. And this is says something about IDEs, right? What you use to program in. There's nothing wrong with Vim. There's nothing wrong with Nano. There's nothing wrong with Notepad, Notepad++. But at times, it's nice to have something to say, hey, you might want to look at this. This doesn't seem right, right? So we also need to pass in our object, right? And that object is, let's call it really generic server. And what is that server? Well, it's an object of API server, right? Cool. All right, so we have that information. Let's do a comment. And that comment is determine if we are communicating to our remote reporting canary, right? Sounds good. We have args, right? What args are we bringing in? Well, we're bringing in packet, which is capture PyShark, right? We're also bringing in server, which is API server object, right? And what are we going to return? Well, let's return a bool, and we can come here and we can hint that we will be returning a bool from our function. And so let's comment that. Return true, false if packet communication is to our reporting server. Cool. Then we come down here, and how do we want to do this? There's multiple ways. So I need to see if that packet coming in actually contains the fields that I need to plug. So let's do an if, and let's say has packet IP and our reporting server is port 8080. It's a web server, so it is TCP. So we can expand on this. We need to also include has packet TCP That's what I'm missing, right? There we are. Got a little zealous. It's all good though. We come down here and we've got to say if packet IP.source is equal to server.ip, and I want to add more conditions. So that's got to equal true, or packet .ip dest orders of operations equals server.ip. Then what? Well, if we're equal, we should return true, right? If we're not, return false. Okay, let's look at this. All right. So we have a function. Our purpose of the function is to return true or false, depending on if we're communicating to our reporting server, our canary. So if the packet coming in has IP and has TCP, we're good. Go further. If packet IP source is equal to server.ip, and how is our parens? Okay, do that. If that's true, or packet.ip.destination equals server IP. So the source and destination is of our remote reporting server. Return true, else return false. Whew. All right. That seems a lot, but I think it's doable. Now we need to enact this into our filter. So come back to our placeholder. Comment check to see if we are communicating to our canary. Alright, so it's a condition. Let's do if is API server. Should rename that. It's kind of ambiguous. Packet. What are we sticking in? We're sticking in server, right? Is true. What do we do? If it's true, return, right? Bail out. Because we don't want to report on what we're reporting on for the report, right? Cool. All right. So we're bailing out if we're talking to our canary, right? We don't need to report on that we're reporting on, right? We don't want that. Get stuck in that loop. I mean, definitely Wapner at 12. Cool. So we got IP, we got UDP, we got TCP. I think we're missing ICMP. Because that is neither, right? So let's add another condition, right? What is this condition? We need to see if the packet is ICMP. All right, how do we do that? Good question. I'm thinking is attribute, right? Packet ICMP, right? We were pinged. Yay, right? Okay, so we were pinged. Now what? I think we need to construct, because pings are different than TCPs and or UDPs. So let's construct our object of right, our packet. And what are we doing? Well, we're doing this. Datagram IP dest is equal to packet IP dest. Right? We have datagram. IP source is IP source, and highest datagram dot highest layer is packet dot highest layer, and I think we need to include the time stamp, right? Equals packet dot time stamp. All right, then what? That's a good question. Well, I guess it all depends on what you want to do, right? I want to ship it off. So let's define another function. Let's do it right up here. Sole purpose of this is to dispatch that message. The other end is an HTTP server. So I'm thinking we're going to have to do a couple things. we're going to have to probably encode that message in a bottle. I'm sorry, encode that message in an encoding, right? Base 64. So let's do that. So let's define a function. Let's call this function conjunction, right? Do report. And what's the purpose of report? It is to dispatch that message. All right, so let's do message, and that is of our defined object. Cool. All right, so coming in is that object that we defined up here, right? This guy. So it's going to have all that information. How do I want to format that? Well, good question. I want to format that like JSON, right? JavaScript object notation, right? And so I think we need to take this object that we defined and create a JSON string for us to dispatch for another system to pluck apart. Whew. All right. Let's get started. Boy. So let's take that message in a bottle and pluck it apart. So what I mean by plucking apart, let's JSONify it, right? So temp equals JSON. Oh, I gotta import JSON. So let's come up here. Let's do an import statement, import JSON. Now JSON should automatically be installed. Right? You shouldn't have to do anything. But if not, it's just a pip install away, right? So JSON, and what are we doing? We are dumps. What are we dumps? We are dumps message, and we need it to be a dictionary. Awesome. So our key value pairs are going to be the keys and then the value of whatever we're passing in, right? Freaking awesome, man. I cannot tell you how nice that is, because other languages force you to do it the hard way, all right? Cool. All right, so we've dumped it. It's a dictionary. Let's start the encoding process, right? So let's do JSON string is equal to temp. Let's do ASCII, right? So we've encoded it. Once it's encoded, let's do our base 64, right? So if by chance there's like a % sign in there, it won't get interpreted as something funky, right? Because we are using HTTP to transport it. So we got JSON string, we've taken our temp, we've encoded it as ASCII, we're shoving it into the string. And let's do base 64. So let's just pick a variable name, B64 equal base 64. Oh, I think we need to do another import. Import base 64. I like the other disclaimer I just said. If you don't have it, I'm sure you do, but it's just a pip install away. Alright, so we defined a variable called B64, right? And what do we need to do? Well, we need a base 64. So that is base 64 dot encode. B64 encode. What are we encoding? We're encoding the JSON string. Sweet. All right. Oh, yeah. Yeah, I think we need to replace. Yeah. All right. Replace the quotes. Okay, so payload, I think, taking B64. Come on. Yeah, I could do some cleanup here. Replace what? Replace that single with a double, right? Okay. All right. So let's say when we report, I want to see something. So let's just print the payload. And I have a really good feeling that this function here can be cleaned up. Why don't you do a comment on how you'd clean this up, man? So let's do our dispatch, right? We're going to use requests. All right, you got another one. And I think requests, you do have to do a pip install. But it's pretty simple, man. Pip install and whatever package you want to install, right? All right. So yeah, we could have done better on our error handling, but I do want to error handle a request a little bit, just to capture, let's say, if the reporting server hiccups or something, right? X equals request. What are we requesting? We're actually going to be doing a get. What are we getting? A good question. Do a placeholder, right? That is for port. We're shoving it into API, and then our query, right? So let's format that. Format. What is this? This is server.ip. All right. First placeholder, second placeholder, server, port. Cool. And then what? Well, we've got our JSON payload, right? Looks about right. So I got to finish that try statement. All right, so let's do catch. Nope, different language. This is accept error. What are we trying to catch? I want to catch connection error. And of course, you're going to want to do a better job with error handling. But as a concept, I think this gets it across, right? So then do logging. We're going to logging to local file, right? And we needed to do this, right? We haven't done it. We needed to do it. So that's just a comment to say, hey, come back to this. Cool. All right. So let's come back to our filter. Whew. You're doing good though. All right. So is API server. No. All right. So are we an ICMP packet? Okay. So we've got our packet constructed, our datagram in this case. All right. And then we need to send it to our reporting mechanism. Boom. All right. That gets dispatched. All right. We're creating. Are we IPv6? No. Right. Let's keep going. Cool. All right. So we're in this if right here. No. Let's do it just like this. Report. Cool. Cool. And let's come up here, delete our statements there, and have it run filter, right? What did we call this? Filter. Cool. And what are we passing in? Packet. All right, we can do that. Let's take our breakpoint off, run it, and see if it blows up, right? It hadn't blown up. That's a good sign. So let's open up our other box. Okay, we got the other box opened up. Oh, generate traffic. All right, let's do some troubleshoot. Cool. And as you can see here, we threw an exception. Cool. Awesome. Okay, let's look at packet. Sniff timestamp. Ah. Come up here. What do we called it? Timestamp. Okay, so sniff timestamp. Okay, where else are we using that? Sniff timestamp. One of these days I'll get it right. But not today. And tomorrow doesn't look good either. Alright, cool. It threw another error right out there. No, okay. If only I could spell. That would be awesome. All right. So we're going to have to probably come down here and fix this too. All right. Right on, right? Nice. Start. Holy camole. Look at that. All right. So let's jump to our canary box and see what we got. Look at that. Look at that. Awesome. Highest layer, ICMP. Those are the traffic. Sweet. All right. So just imagine what you can do with this powerful, powerful, beautiful rainbow that we've just painted, right? Seriously, think about it. We could freaking push back that red team, right? We could just freaking drive that ball into the goal. We did it, man. Yeah, I hope this was fun. I hope this was entertaining. I hope you might have learned a thing or two. Like I said, man, this is just another tool in your belt, right? Just freaking level up that technology. This is freaking awesome. As always, if you have any questions, comments, concerns, if you want me to share the source, put it in the comments, man. If you like this, hit the subscribe, right? Do the thumbs up. Tap that bell. And until next time.